Namaskaram everyone. Welcome back to the 17th episode of our Master Unreal series, and in this episode we are going to continue our inventory management system. In the last episode we implemented the inventory grid, the discard grid where you can place your items, and now in this episode we are going to design the inventory case which will hold your weapons and will show the weapons on the widget blueprint. So let's just get started. Okay, so we are in our editor now. Let's begin from the items. We had this item definition base class. That is what gets spawned in the world. Now we are going to create another class, object select bp underscore item instance base. So this is the instance of the item that you just equipped. So this item definition class will be converted into instance, and that is what you will store in your array that is keeping track of the items that you have in your inventory. So let's save it, open it up. First is what is the stack count? That basically represents the quantity of this particular item you have in your inventory. So I'm going to set it integer. Next would be the item definition. This will allow you to access item mesh, name, description, and some default information. So BP item definition base creates another variable, and this is going to be the most extensively used variable. So inventory config. And now let's create the structure for this. So in the utilities under structures, we are going to create a structure, name it s underscore inventory config. Now this keeps track of default rotation. Select for rotator type, create two more variables. This would be default scale. So every item has its own size by default. We might need to adjust them based on our inventory look and feel. That's why I'm creating these two variables, and this would be vector. Now this third variable will allow you to store the custom parameters. This is nothing but storing some default values that would be required to position the item correctly in the inventory, which can vary for each item. Okay, so we need a different type for this. So let's create another structure. Give it a name s underscore item custom offset. And let's also add map. So it's item custom offset map. And this is what we are going to equip here. So item custom offset map. Save it. Go inside this now. And now here we are going to add vertically inverted offset. Type would be vector 2D. Create 6 variables of this type. Next would be vertical offset, horizontal offset, horizontally inverted offset, offset multiplier. It's okay, don't panic, just write it down, and as we move ahead I'll tell you what is the use of each value. Save all now. And now once you go to instance base, you can change its type to s inventory config, hit compile, and now you can expand. You will have all the values. Now the default scale would be 1. So now any item you add in your inventory will have this 1,1,1 scale. Now let's start from weapons. I'll create blueprint class, object parent, and bp underscore weapon instance base, and this instance will represent instance of every kind of weapon. And I'll create a variable, name it weapon type, and it would have gameplay tag. Now every gun will have an instance again, so I'll create a blueprint object parent, so bp underscore gun instance base. This will allow you to store the weapon stats and all that stuff, which we are not going into right now. So just let it be empty. Once we are done with the inventory management, I'll tell you how to store the configurations of guns, like how much damage capacity each weapon has, and you can later on then upgrade them. So this is the reason why we are creating this. Right now it will not be used, but this is required so that you can derive from this class. Okay, first open the weapon instance base. Under class settings, change the parent class to item instance base. I forgot that we have to derive from this. Now hit compile again. And in the gun instance base, change the parent class under class settings to weapon instance base. So it should not be object. I made a mistake. Now if you save and compile, under class defaults, you will see your inventory config is present. Now the assault rifle, let's create another blueprint class. This time derive it from gun instance base. Select, name it BP underscore assault rifle instance. Just duplicate this in handgun, copy in shotgun as well, copy here. Now change the name. This one would be handgun instance. This one would be shotgun instance. Save all, hit compile once. And now if you go to shotgun instance, you can see the default scale is 111, which was derived from the item instance base. Okay, one more thing, the item definition in the BP item instance base, this has to be class reference. Okay, save and compile. Now if you go to your shotgun instance, you will be able to select the class. Now in this BP shotgun instance, we will choose BP shotgun definition. Do the same for all three guns. I'll go in the handgun. I'll select the handgun definition. In the rifle, I'll go in the instance and I'll select the rifle definition. Okay, all set, save all, compile. And now we come to B inventory case. Let's go in viewport, add a scene capture component. The x direction value would be 102, y would be -40, and z would be 270. The rotation in the x direction would be 0, in y direction it would be -90, and the z would be 180. And now change the projection type to orthographic, ortho width, set it to 540, and save and compile. So this is what is going to capture your items that will be placed in the viewport. So do not change even a unit in the location, rotation, and scale of this particular camera. Now once you are done, you will see item lying on ground that would be of type item definition, and then you have to pick it up, add it in your inventory. So to add it in your inventory, we will convert it into item instance and then we will add it. So for that we have to go in the BPC inventory manager. This is the event that accepts the item. So when you pick the item, right now we will not play preview, so let's disconnect it, and instead we will fire on send pickup choice. Set the accepted check mark to true so that it gets in your inventory automatically. And now in the weapon case graph, we will create an event to add the item in the inventory. So create a custom event, name it add item in inventory. Now we will create a variable that will keep track of your inventory. So owned items. So this is what is going to store your items. So now I'm going to create a structure for this. Go in the utility structure, search for a structure, and this is what I call as inventory item. Open it. Now this will possess the definition, instance class, definition class, what is the grid position in your case, how it is placed, is it placed vertically or is it placed horizontally. Next is item size, so how many grid boxes is it going to take. Then is it placed inverted, so like horizontally flipped or vertically flipped. Okay, and now about the type. So the definition would be BP item definition base. Instance would be BP item instance base. Grid position would be a vector 2D. Placed vertically would be a boolean because it is either placed vertically or horizontally. Item size would be vector 2D and place inverted boolean. Save it, go back to inventory manager, change the owned items type to inventory item and select it, change its variable type to array. Now this is going to keep track of our items. And now, like I said before, we need to construct the item instance because we are going to receive the nearest item that we are about to equip, and it is of type B item. So let's bring it out here. Get the item definition. Now to get the instance class, we will go in the inventory system, item definition base, and let's create another one. Let's name it instance class, and the type would be item instance base class reference. So this is just going to hold the name of the class so that we can construct the instance whenever it is found. Let's delete all this and rename it to on item picked instead of add item in inventory, and I will create a function for this. I'll create add item. Okay, so now we have a function that will be called by this on item picked event. And the item picked will receive the item that we have to pick, and the type would be B item, which we created in the previous episodes. And this would be passed to the add item. So I'll create an input, just name it item and pass it to this. Make sure the item type is B item in this as well. Get the item definition, get the instance class variable that we just created. And now let's construct the object from this class. Also go in the item instance base, select the stack count, make it expose on spawn and instance editables so that you can also add the stack count when you create the object. Once we are done with all the logics, we will deal with this, but right now let's just keep it one. Now here we are going to store a temporary variable, temp inventory item. Here we are going to set its value, and for this we have to make the inventory item. So this needs a definition, pass the definition here. It needs the instance, pass the instance here. Rest of the stuff, let's keep it default. Now we need to spawn this item in the world, and when you will spawn, you will get the grid size of this item, how many blocks it's going to take. So for this, I'm going to go inside my case. I'm going to create a function, spawn item. Now the spawn item needs the inventory item. Type would be S inventory item. It is also going to require a key of this item that will allow us to identify it uniquely among the other items. So the key would be of integer type. And now we are going to add the mesh. So add static mesh component. Let's split it. Location rotation would be 0. So remember, in the inventory config we created default rot and scale. We are going to use it here. So I'll get the inventory item variable first. I'll break this inventory variable and I'll select it, and in the default category I will hide unconnected pins. I will make instance and definition as visible. I will then get the instance. From instance I will get the inventory config, and I'm going to split this and pass the scale. Just the scale, not rot. At this moment we don't want this, because the scale is the one that will determine how big your item is in the inventory, and based on that scale it is going to calculate the grid size. So when you spawn, case wants to know what is the comfortable size that you have allotted to this item. And now after this I'm going to create a local variable, call it mesh component. Type would be static mesh component, object reference, and now we can set its value. And now this will create the mesh component. Now we have to provide that mesh. So that mesh is present in the definition. So get item mesh, and we are going to call set static mesh method, pass it the component in the target and an item mesh in the new mesh. Good, now you have made this far. Now let's go for the mathematical part. Now we need to determine where to place this item by default. So we will create a function, calculate relative position. Okay, and just return nothing for now and call it here. And now this will give you the location. So lock, and the type would be vector. And this is also going to give you the grid size, and the type would be vector 2D because there is no Z value. Once you receive both of them, set relative location and rotation, and you can remove this default scene component. Instead, use the mesh component variable, pass the location to lock, and let the rotation be 0. And once you do this, this item will be available and it will be captured by the scene capture component. So for the scene capture component, we are going to create a render target. In the textures folder, you can create inventory texture render target 2D, save it, open this and give it a size of 1800 by 1800. Save it, create a material, go inside, select the material domain to user interface, blend mode to translucent, do the same thing, 1 minus, and plug it into opacity and RGB to final color. Once you have that, save and apply. Also, let's organize these textures. So let's move the item texture here, player texture to here, and the inventory texture to here. Okay, we are all good. Save all. Now let's go to our widgets, go in the inventory, add the image components, and this should be placed below the grid case. Set its anchors to top middle, and the X position would be minus 864. The size would be 1728. Size Y would be 1728, and set the image to inventory texture. Once you have added the item, we would like to refresh the scene capture component. So for this, I'm going to go inside the event graph, create a custom event, name it refresh scene, and I'll bring this here. Show only actor components, get the reference to self. So this will update the list. Now let's call that here refresh scene. And now we are going to create another variable, that is mesh map. Change its type to integer map, and the type would be static mesh component object reference. And let's call it here add, pass it to this, get the key from the variables, pass it here, duplicate this mesh component, connect this to this. Why we did this is because we want to keep track of all the meshes that are there so that we can update their position whenever user picks and move them. So we have to keep a map. Cool, now we have the item. So now in the add item of BPC inventory manager, we can call that. So we will use this case actor and call spawn item here, and the inventory item would be this. This also needs a key. So now we have to create the key. So let's go before adding it. Let's create a local variable item key, type integer, and it is nothing but the length of the owned items. This would be the future index once it gets added. So that's the reason we are taking length. Bring it here. Okay, now we can use that here, get item key, pass the key here. Now this spawn item needs to return the grid size. So grid size, change the type to vector 2D, and let's plug this here. Okay, save and compile. Go back to inventory manager, you will have your grid size. Now we also need to find the slot and check if it's available or not. We are going to do that in the next episode. Right now we are just going to place the item in the widget. So right now we are just going to set members in inventory item, connect this to this, pass the temporary inventory item here in the structure reference, and let's select this in the default category. Go for grid position 0 0. Item size is what we receive from the grid size, and this is not placed vertically at this moment, and these are the details that we want to update, and once they are updated we want to set them to inventory item. So this is the way you update the specific fields in the structure. Okay, let me do one thing, is that create a function, call it find slot and place item, and this is going to return nothing at this moment, and place this one here. So spawn the item, find the available slot and place it, update the details. This will give you the grid position as well. So let's go for grid position, type would be vector 2D, and this is also going to give more details, but let's just assume this placed the item. We updated it, we set it in the temp inventory item, and now we are going to add it in the owned items. And to add it, just simply call this owned items variable, add, pass this to this, temporary item will be plugged here, and finally it's going to return. Cool, so now we have added the item. And now let's set the default values. Under your weapons, guns, assault rifle, definition class, you added this instance class variable, right? So you have to provide the instance here. So it will be assault rifle, go back, do the same for handgun, provide the handgun instance, and let's add it in shotgun as well. And make sure in the instance base you have the default value of scale to 111. Save all again. Now once this is done, go in the event graph of inventory manager, and here when we make a choice we have to call this add item here. So add item function. So what would be the item? It is nothing but the nearest item. So when you pick, add item will be called, and here it will perform all the logic. And now hit compile and play, press E, we picked it up, and now you can see your weapon is here. Now we need to rotate it. So that's the reason we created this default rotation. Now since we are using the Lyra guns, I can just go to BP gun instance base, and in this instance I can provide Y minus 90 and Z would be 180. So now since rifle, handgun and shotgun is derived from this class, that's why they acquired these default values as well. And now we need to provide that rotation here as well. Get the inventory item and then break S inventory item. From instance, I will get the inventory config and I will split it and I will provide the default rotation here. Cool. Now if I hit compile and play, press okay, now I see my gun is placed correctly. But if you have any other gun that does not require the rotation, you can just go to its individual class and set the rotation to 0. Now go back. So I'm barely able to see my guns on this background. So what I can do is in the grid case under graph, when we are drawing the primary grid, we can just expand this and we can use this draw box, plug it here, plug it here. I can set it to 0, 0, and the size would be multiply case rows, case columns, and the unit size. Case rows goes here. Oh, it should be case columns. X goes here, Y goes here, and we split this size, and the X goes in Y, Y goes in X. And let's change the tint to hex linear 020202C0. Press OK, compile, play. Okay, now we can see that my item is placed exactly here. So the way camera is placed, this is the origin. So whenever you will pick any item, that will be placed exactly here, 0, 0. And if you go in the left, there are 10 blocks. And if you go up, there are 6 blocks. So what we need to do is first, we will shift this particular item to this position. So that means out of 10, I have to push 8 blocks in the left and 6 blocks on top. That way we will reach here. And from here, we can add the grid position multiplied by unit size to push it wherever the algorithms tell us. So let's say if algorithm find out this position, then we need to push the item 1 unit down and 3 units in the right. So the weapon will start from here and it will go up to here. So that's the gist, or I must say the core of how the item placement and the position calculation will work out. If I equip item again, let's say this time shotgun, you see my item is placed here again. So this is the origin, or I must say the center where the 0, 0 lies. So now our goal is to push this item exactly here. So we are still going to assume that this function is going to give us position, and for now it's 0, 0. So it will be placed exactly where we want by the algorithm. So we will go in the spawn item, and now this is the calculate relative position function. So the first thing we want here is the inventory item, then the mesh component. Now, you know, in the previous episode, I told you that there are only 2 ways you can place item, either lying on ground or it is flipped vertically. So these are the 2 only possible situations allowed. So we have to check how the item is placed out of these 2 situations. So I'll create this function, name it is rotated, and I'll just return it. And in the input, I will take rotation, type would be rotator, and I'll split this. I will divide it by 90 degree. I'll divide it by 90 degree and then I will perform a division to get whole and the remainder, and the divisor would be 2. And then I will check if remainder is not equal to 0, and then I'll pass here, and the variable name is rotated. So let's say if you rotate the item by 90 degrees, this will give 1, and it is not equals to 0, that means it is placed vertically. But let's say you rotate it by 180 degrees, that means nothing, you just inverted, so we don't consider as a rotation. So that's the reason we want to check if from horizontal you gone into vertical situation. So that's the reason we are doing this. Now this function would be pure because it is not modifying anything and either using any external state. And here I will split it up. I'll get the inventory config. This inventory config is going to give me the default rotation. Now I can split this to get the rotation. I will check is rotated. So if it is rotated, then I will create a local variable is rotated, and now we need a function to calculate the grid size. So I'll create a function calculate grid size. Now this grid size first needs to know the item extent, that is a vector, and it also needs to know whether the Y is rotated or not. Again, I'm going to just return it, and the result would be grid size vector 2D. Split this. Awesome. Now get the item extent, multiply it by 2, right click on this, convert into a float single precision. This will multiply all the values by 2. Now this will give us the full size in all three directions of the item, of the mesh. Once I get that, I will divide it. And divide by what? The box size. So here we will create another variable, that is box size, and I'll go for float, bring it here, connect this here, and I'll split this, and then this will give us the number of boxes this item is covering. So this will give us the float values, but we want an integer, a whole number, so I'll use ceil. This will give us the nearest larger number. So if it's 1.6, it will take it to 2. If it's 1.2, it will take it to 2 again. So anything that is in decimal, just take it to the next number. I'll do this 3 times for 3 values. 1, 2, 3. Okay, then I will create a vector and I'll plug this because these are integers and we have to convert back to float. And now I will split it again. And now I will create select float, and the y will go into y. And remember, the rotation is only allowed in the y direction. Remember, only in y direction. If you are rotating any other axis, x or z, please don't do that. Instead, just re-import with the default rotation value. Once you are done, we are going to check if y is rotated. So if y is rotated, I will plug z here and x here. Alright, and then this will go in the x. And also let me rename this function to is y rotated to make it more precise, and this would be calculate grid size. This is done, compile. Now once this is done, you can call this calculate grid size here. You can place is y rotated here and use get component bounds, pass the mesh component, pass the extent here. So I'll just create a local variable item grid size, and it would be of type vector 2D. Once this is done, we are going to go for a sequence node. Now I want to create another variable in the actor component, that is distance from origin. Now this is something that I have calculated on my own. So the item is placed here and the item is 10 blocks away from the left and 6 blocks away from the top. The 65 by 65 grid size that we wrote while spawning the inventory was for the widget that was in pixels, but right now we are calculating the coordinates, the mathematical coordinates. So we have to translate from coordinate to pixels. So I did some calculations and formulations and I found out that one block is covered if you move the item 20 units. So in widget it is 65 pixels to cover one box, and in the viewport where your 3D mesh are placed, it is 20 units. So if you move 20 units, you will cover one box. So that's how we translate the coordinates into the pixels for widget. So the distance from origin would be a vector 2D. Compile it. Like I said, Unreal Engine takes it opposite. The x direction is 120, that is in the top, and y direction is 200, that is in the left. So this is the distance from the origin. Now we would like to get the mesh component. We would like to get it local bounds. So this get local bounds will give us the min and max position of the mesh. So first we want to know how much we want to push in x, that is in the up direction. So let's make it float, and here I'll split this. So what I will do is I'll get this distance from origin, split this pin x and subtract, and the value that I'm going to subtract is the max z, but I'll take the absolute value of it because local bounds can be negative, component bounds will be positive always because it is going to give you the size. This is going to give you the coordinates. Okay, so I'll plug this here. So I'll plug this here. So now this is going to give us the result, and then we would like to multiply by -1. Okay, so if you go negative, then only you will move in the top direction. If you make it positive, you will move in the bottom direction. Once this is done, then we would like to set this value. So let's connect this to this, and the x goes here. All right, that is for x. Now we will go for y. So I'll create another variable, that is y float. Remember, we are calculating how much we have to push. Set the y here. So we will choose minimum y, absolute, and we would like to subtract. Let's connect this pin here, remove this, and get the distance from origin here and plug the y here. Once you have this, just plug it, don't multiply it, because the positive means you have to push in left. If it is negative, then you have to push in right. So we want to push in left. So whatever the value is, we will just place it. Okay, we have x and y. So now we just return it, split this, x will go here, y will go here. And z will be 0 because we do not have any height. We are placing it on ground completely. And and let's put this item grid size here, connect this to this, and get the grid size here. So now in the inventory case, spawn item, we can provide the two things that it needs. One is the mesh component, so let's duplicate and pass it. And the inventory item, let's pass it from here. Once you are done, hit compile, play, collect any item that you like, and you see you have your item here. Now don't worry about that E and the equipped area because we haven't connected it with our inventory system, but right now the main idea is to position every gun, every item that you receive in the top left. Now if I exit and play again, collect shotgun and press E, you can see it is also placed in the top left. Now both have different sizes though. So that's it for this video. Like it, share it to your friends, subscribe to the channel. And I know there was no dynamism in this particular video. Everything was so static, but it was very much required. I wanted you to understand how the placement system will work. Now in the next episode, we are going to create the algorithm that is going to take care of the inventory management, where to place items, how many items are placed, where they are placed, how much space is available for placement, how to toggle between the discard and the primary case, and then finally you will be able to pick and move items and place them even vertically or horizontally inverted. So till then, stay tuned and I'll see you in the next episode. Bye.